Okay, guys, welcome back. Full audience. That's nice to see you on Friday morning. And I have Serg Masis next to me, who is presenting this topic for the very first time, apparently. He's a little nervous, so give him a little round of applause for encouragement. Thank you. Did it feel good? Did it feel nice?
Yeah, it's
Yes,
fine.
your mic is on. Okay.
Awesome.
And I thought it is a metaphor that we are talking about puppies, but apparently no, we are talking about little puppies and how to train them. So I won't talk any longer. Let's hear it.
All right. Thank you. Thank you so much for the introduction. All right. About me a little bit. I'm a data scientist at Syngenta. I work, in agriculture, but analyzing satellite images and that sort of thing, making predictive models on crops. I also wrote a best-selling book, and I'm on to a next book called DIY AI, which more or less connects to what we're going to talk about. And before, I also worked in development for a long time, in web and mobile app development for over 10 years. And that's how I got involved in data science. First of all, a disclaimer. No puppies were harmed. So rest assured, no puppies were harmed. Also, this is a fun talk. It is technical, but it's meant to be fun. And I hope you are infected with that funness about AI and you want to engage with AI. All right, so I've broken down the topic into the problem, the approach, the implementation, and some takeaways, some lessons learned. So first we're going to go through the problem. But first, let me introduce you to the subject. This is Tilly. This is where you all go, That's what you do when you meet like your neighbor's child or your nephew for the first time, even though he might be, the ugliest thing in the world. All right, so Tilly is a year old, and she goes where I go, Here she is, helping me write my book, and here she is, like, hanging out in bed, and there she's in the car in her own little seat, right? So, and we have fun. I don't know, there's no audio, but I like to take videos of her. Here she is in slow motion. I don't know, the contrast isn't really good, but look what I do to her. That's AI. So I turn her into some kind of cyborg. It doesn't look too great on the screen, but it's kind of cool. All right, so she can also be a handful. So here's an example what goes on. So here she has a little pad where she does her business. We call it her business. And there she goes. And here I realize, uh-oh, it's in the wrong place, right? So she does her little walk of shame, as she does, and she's like, I did something wrong. And so I come around, and I show her, this is not in the right place. Video's a bit grainy, I'm sorry. And, I put her to the ground, and I'm like, now I have to clean this, right? Such a bother, right? So the important thing about feedback is that it has to be immediate, constant, and consistent. And that's really hard. I can't always be there to give her that feedback. So boundaries of the pad are the hardest thing to understand. She understood that she had to use the pad, but she thinks, oh, all my 4 feet are in the pad. That's good enough. No, right? Okay, now I'll go through the approach. This is the solution. I mean, originally I just thought of this. Okay, I have some camera. I have some machine learning magic. I have something that tells me, is it a 1 or a 2? Do I have to explain what a 1 or a 2 is? No? Okay. And then if it's out of the pad, right? Essentially, I'm not checking if the 1 or 2 are out of the pad, but if her tailbone is out of the pad, because that's an indication that it'll be out of the pad. And then I give her some feedback. If you know, if it was in the pad, then hooray, I tell her, good girl, that's what I tell her. Or if not, I give her some like negative sound, you know, like maybe like Darth Vader or something. So, I mean, I said machine learning, but what is machine learning? Basically, it's here's a very simple definition. It's implementation of computer software that can learn autonomously. It's pretty much that simple. Um, and the kind of machine learning we're implementing is called supervised learning. And for those of you that don't know, it's there's three kinds of machine learning roughly, and this is one of them. And this is the kind where it learns by examples, where you have data and you pair it with answers or labels. So in this case, you say, well, if the data is 1 and the answer is 2, and here we have data is 2 and the answer is 4, then what is the kind of underlying equation that connects them both? So that's what machine learning finds. In this case, it found y equals x times 2, right? So that becomes the model. The model is this equation. So the model is simply something that takes an input and turns it into an output, and that's what the machine learning algorithm learns. So the kind of task we're going to do with machine learning is called pose estimation. And, well, one of them. And this is an example from a project I worked on for driver alertness detection 4 years ago. And, so what it finds is the facial landmarks. So here you see the facial landmarks, right? And then I do I convert the points to 3D so I can, perhaps have a better understanding of where the face is facing and that sort of thing. But the important thing is that the pose estimation model is the one that finds the points, that finds the position of the points of parts of the body. But then gesture recognition is something else. Can you tell me what she's doing right now? Well, actually, she's sneezing, but no. No. But she could be. She is yawning. She is yawning. But she could be sneezing, right? Because you can't tell from a single frame. And that's the whole point of gesture recognition. You need more than one frame, usually. I mean, sometimes, depending, like sign language or something like that, maybe a single frame is enough, but mostly you need more than one frame. So it's in this case, very useful. So here we go with implementation. Oops, I went forward. Okay, so first, gathering training data. So I gathered 274 videos. I know it doesn't sound like a whole lot, but it was weeks worth of work to get that many videos. Some of them she's not actually doing anything, just going in front of the pad, running around, playing. But it is important to know when is she doing what we're trying to detect. So 274 videos of her in front of the camera. And then here's the challenge. For pose detection, we need the points of the body. So like this is a tennis match, and someone is going here painstakingly and adding little points to every part of Federer's body. That must not be a fun process. They're going frame by frame. Of course, now systems automatically, through like assisted, partially supervised system might help them, throughout the process of adding the points. But I didn't want to do that. I didn't want to go frame by frame, hundreds of videos, adding points. So I found a library. And this is a library in Python that neuroscientists from Harvard and this university I can't pronounce developed this toolbox for lab animals for scientific use cases. So here we have some rats, and this is for them to see the movement of rats. It's mostly to understand animal behavior, which is pretty much also what I'm doing, it's just not in a lab environment. And there's also a model zoo, what they call a model zoo, with pre-trained pose estimation models for domestic animals. And here we go. We have one for a dog, right? So it happens to work. So the way this pose estimation model works, it finds these points, only these points. It can't find any other point, you know, in the dog, but only these ones, and that's good enough for me. So here they're properly annotated. You see all the, I think they're 19 points. And what it is to find a point is to find an XY coordinate for that point. For an individual image, in this case, an individual frame. So for each frame, what I'm finding is the XY location of each one of these points. And I'm doing that for every video. So something I did, and I've used this in other pose detection projects, was convert the 2D landmarks to 3D. And of course, this library also comes with a mechanism for doing 3D, but it does it when you have multiple cameras. In this case, I couldn't necessarily rely on multiple cameras, given the kind of implementation I wanted to use. So what you do is you get, like, you do a camera calibration, you take one of these like checkboard kind of things, you print it out, you put it in front of your camera, and then it will learn, you know, from the position of these things. It will calibrate it and find like the intrinsic coefficients of the camera, what's called. And with that, you can create a projection matrix, which can take anything in 2D and turn it roughly into 3D. It's not perfect. It's better to have multiple cameras because you can use something more sophisticated. But I tried this. It was too inaccurate. What ended up happening is, you know, when I converted many of the points from 2D to 3D, I found out like the dog was all of a sudden like, you know, you have like a depth coordinate, Z. All of a sudden when the coordinate is like minus something, you know, that can't be possible. The dog didn't go underground. So I figured, well, there's something off about this. Yeah, it works well when the camera is fixed in a single position and the object is not occluded too much. So there's even regardless, even with the 2D mechanism, there was a lot of issues with the pose estimation. Like there were cases. Of course, can you see the dog on here? Yeah, she's running. The camera isn't that fast, so you see a blur and then you see a bunch of dots on the bed. Yeah, that's not her. So of course, like there were things I had to correct for, and I had to remove it from the data set and make sure that whatever kind of processing step I took, I used it, you know, for later. I recorded like this. Something I didn't mention is, in addition to the XY coordinate for each point, it also gives a probability that's correct, right? So I had to raise the probability to get rid of points that didn't make sense, like this one, or like those ones. And some cases I had to do other kind of heuristics to get rid of points that did not make sense. So that's how I ended up with, you know, 239 videos. Again, it doesn't sound like a lot, but there's some magic that happens that makes it a lot more. So that's about labeling the actual points, you know. But what about labeling the gestures? So here we have a video, right? And so I go through the video, and this is part of the process that I had to go through every video and actually watch it and say, okay, on this frame, number 1 started, and on this frame, number 1 stopped. And I could do that if there was more than one instance, which there rarely was. I could put it inside the same video as a label. And that by default means that everything else is 0, right? So imagine every frame, it has a 0, 1, or a 2 associated to it. So that's a process, but I don't really have to put manually like a 0 or 1 on every frame. I just have to the start and the finish, and then I have a script do that automatically. Okay, so the modeling approach, imagine I have every video, and then so I have the zeros, and then 1, zeros, and then zeros, and then 2, and zeros, and so on for each video, right? And then what I'm going to use, because this is time related to time, time is an important factor in gesture recognition. I can't use any like neural network. I have to use something called a recurrent neural network that's going to take that time into account. And the specific kind of recurrent neural network I use is a long short-term memory one, LSTM. So as for the data preparation, I mean, this can be a little misleading because you think, okay, well, I'm feeding images to it, but I could, but it's not necessary in this case because we have something more valuable than the images. We have the position of each body part within each frame, within, the video or each image, right? So we don't actually need like those position, the images. So the data preparation is different than you would expect. It's what it is imagine a timeline where you have T for each video, right? And so we're connecting two dots. Well, they're not really two dots, but we're connecting two things. We're connecting a gesture in the future to poses in the past, right? So what that means is that for every time step in that video, we're going to be connecting, we're going to connecting this. So imagine a little matrix that's going along and it's capturing all these different things. So it's capturing for each body part, XY coordinates, for each time step in the past, for each gesture in the future, right? So that's how you turn 239 videos, which doesn't seem like a lot, to 298,000 samples, right? So you end up with a lot more. That being said, it doesn't mean necessarily that the model is going to understand everything about, but for this specific very narrow use case of my dog in using my pad, it will work. So now a bit about feature selection, because like here we talked about body parts, right? So we have all these, P body parts, but we don't have to use all of them. Some of them might not be like important for this problem. So we have to look at what are the cases in which it is important. So we have all these different points, right? All these different body parts, but like for this particular problem, I found some correlate more with the gesture than not, right? So the tailbone is particularly important because when it goes closer to the ground, closer to the feet, that's when you know something's about to happen, right? So you also have, as a kind of counterbalance to that, the throat or the neck. The throat is another important point. And so you can measure distances like that. You expect a kind of model to learn these relationships because they're very complex. I couldn't possibly put it like in some kind of heuristic and tell you, oh yeah, this is the distance and this. I mean, I know it has to do with that, but the model's doing it for you. Well, the model algorithm. And so you have all these points, and these are the ones that, more or less mattered the most. Some more than others. So as for training the models, I tried many different combinations of body parts, which is the feature selection I spoke of, and many values of n. So that's important. How far back do we need to know to understand that a gesture is about to happen? Is that, a minute? Is that, 5 seconds? What is it? So that I tried many values of n. I also, of course, there's a bunch of other hyperparameters that have to do with LSTM that I also tested. And so at the end, there were over 1,000 models, evaluated them, figure out which one worked best. I haven't spoken about it at length, but another important part of this problem is detecting where the pad ends and starts, right? So that's a separate model, but that's a very simple model. That's a convolutional neural network. It's only simple because, I'm not, classifying between one thing or another. It's just a single kind of entity that I'm trying to detect the corners of. And I probably could have used something more simple, based on, traditional like computer vision techniques, but, the convolutional neural network works very well. And so I trained that. And what I did to use that, just to give a little bit of understanding of what that was, is just for every video I took, certain like samples of frames and manually put four corners and said, okay, these are the four corners of this pad. So at the end, for the gesture classification model, we had a 97.8 accuracy with a fairly high precision for most classes, being 2, 1, and 0. 0 of course being the highest with over 99, and 2 being the lowest because there are not many examples of 2. So, am I done? Not really, I don't know if you see this, but this is Captain America, right? And of course, the training is done, but the training was done in a computer with a GPU. It has images of slightly better quality that you would expect in the real life. And when inference is what we do to actually put the model into production, it's when it's actually being used, and it's not to be done in a computer with a GPU, right? And it's potentially being used in situations that the model wasn't trained to deal with, right? I dealt with, videos at nighttime, in the morning, in the afternoon, when it was cloudy, like all kinds of circumstances, but, I can't possibly cover everything. So, it's time to have the Raspberry Pi with 1 gigabyte of RAM to take the heavy lifting. So this is like Chris Evans with the Thor, kind of acts, like let's see, let's see if it will work. So it has to deal with 94 megabyte dog pose detection model, a 7 megabyte pad pose detection model, and the 237 megabyte gesture classification model. So here's where we run with a latency problem. So you understand, like there's the Raspberry Pi. Inside the Raspberry Pi, you have Python. It's an interpreter, but I'm doing something that's called Seisonize it. So it should, in theory, work better. And then within it, I have mostly two kinds of libraries dealing with heavy lifting of making this pipeline work. So I have OpenCV, which does some pre-processing to the images. I didn't speak too much about, but it scales them down. In real time, what it would be taking is the feed from the camera and scaling it and all that, right? And then you have the pose estimation model that extracts the points. Then you have, both pose estimation models. And then you have the gesture recognition model. And then, you combine both and you make is she a good girl? That's the question we're trying to figure out, right? So this is a problem. This is the latency that's unavoidable between the camera and the Raspberry Pi, which is variable, unfortunately. And then you have how much it takes to do the pre-processing, the pose estimation, and gesture recognition. If you add all this up, it means I can only process 2 frames per second. That's not good, right? Especially if I train a model on 30 frames per second. That won't work. So of course, this was a total failure. But then, okay, let's step back. Let's see how we can improve this. So this is the latency solution I came up with. Let's get rid of Python. I love Python, but it's not the best language for a Raspberry Pi. So I was able to cut down a little bit on certain things. The pre-processing certainly, because OpenCV on C++ works a lot better. And then pose estimation is a lot quicker. Of course, it's all compiled. It's beautifully compiled. You're going to get a lot better results. And so what this meant is that, okay, all of a sudden, well, maybe not 30 frames per second on this 1 gigabyte RAM Raspberry Pi, but now I could do 10. And that's an improvement from 2 to 10, right? So invariably, what this meant was now I would have to retrain my models all over again to deal with the 10 frames per second. So it meant that, like once, now it meant I would be only taking 1 of every 3 frames. So it's a hit to accuracy. I think I didn't publish it here, but it was like a 1% hit to accuracy. But it was worth it because otherwise the model's not useful in the environment I intended to be. And I'm not exactly going to be connecting my computer and my GPU all day for this. It's not worth it. So now comes the bells and whistles because when I ask here, is she a good girl? I mean, the whole point is giving back feedback, right? So I have to give the feedback. And so I connected a Bluetooth. You can't see it well, but this is a Bluetooth speaker. Um, and um, and so I recorded several versions of, good girl and, oh, and no, not the Darth Vader stuff. But the whole point is to show the good girl when she successfully completed, a one or two, and uh-oh when it's about to be impending, and then I forget what a more ominous sound when she's definitely done it wrong. um, so so this is a case. Again, sound is not working, but this is first time working in the wild. I put a light source over there. So here she got an uh-oh because it seemed like she was going in the wrong place. And so successful. Ah, good girl. So she got that. And she's that's odd. So she rushes. She's like, this was weird. She got a bit scared. Yeah. So a few takeaways. Um, First of all, sound design. I think I should have paid more attention to the sounds used for the feedback, since it seemed to be a bit anxiety-inducing to the dog. Um, it's not something I thought through too much, right? But what I noticed while this was in practice was that, like it corrected her behavior. I can't say so much because I didn't measure too much of the results, but I think I was less time spending cleaning up after her, and that's a good sign. But I do think the sounds were a bit strange for her. And then this is here comes C++. I should have tested latency earlier. I suspected all along that Python wouldn't be able to handle it. Um, but I'm so used to Python and honestly a little bit adverse to C++. I'm like, look at the semicolon, yuck. Who likes that? All right. I guess yes, I'm just used to C++. And I was afraid to try it first, but I honestly probably should have written everything in C++ from the beginning. Because yeah, it was quite a bit of work of moving hundreds of lines of code from one thing to another. So another thing is occlusion. Like this is more like a design issue. I probably some key points are almost always occluded, such as elbows, because of course her legs are really short. And more importantly, the throat. That's a very important key point, and sometimes it's not very well located. So I probably should have used a top view angle, which meant fixing the camera on the top with a slight inclination to get her legs as well, to a degree. And it had to be a consistent camera position to work much better. But I couldn't do that from where it was sitting. So here's a question. Before I open up to questions, I actually ended a lot earlier than I expected. Hopefully it wasn't too quick. But does do-it-yourself AI interest you? Show of hands. Who of you want to play around with AI? All right. Well, this is kind of a shameless plug, but I'm writing a book with this title, DIY AI, and it's all about like projects like this, but like not this one because I don't expect everybody to have a dog, but Stuff like sound recognition, facial recognition, pose detection, fun stuff. Also generative art, generative music, and so on. So it has a chapter devoted to each one of these topics, and hopefully, this time this year, able to get it. And yeah, I just wanted to understand, if in the software community, people were interested in playing around with AI. Because one of the things I think is that AI seems like this, either magical thing or this very daunting, like crazy thing that, but now it's never been more accessible. Anybody can, play around with these things. Compute is very cheap. Graphics cards have also gone down in price. You want to do it. And so I think there's an opening for people that wanna do these sort of projects at home. So this is it. I mean, it ended up a lot earlier. FYI, these images, a funny story. Not only the opening image, but this image, these were generative with stable diffusion. Yeah, when I told them what I write the name of the presentation, this is what it comes up with. So I figured it'd be kind of fun to do that. And, should you want to, you can contact me on any of these platforms, GitHub or Twitter. So I understand Twitter is no longer cool, but I'm still figuring out Mastodon, to be honest. So I didn't put any Mastodon stuff in there because my profile is is sucky on Mastodon. But you can certainly tweet at me for now. So, any questions?
Okay, thank you very much. Um, I am also interested, how many of you have dogs at home? Specifically dogs. Okay, that's little people for such a topic. And how many of you have cats? That's my point. So does this system, I mean, not this specifically, but maybe customized a little and so on, do you see it working for cats too?
Yeah, certainly.
No problem.
No problem. You just
Okay,
have to
you can
use
stay.
in the model suite, there's a cat model as well.
I wasn't there for the half of it.
Okay.
Okay, you need to answer questions like I was there all the time.
Oh, okay.
Don't bust me. Anyway, do you have any questions from the audience? Yes, let's go.
Hi, so thank you. First of all, thank you so much for a very interesting presentation, Serg. But the question I have here is this experiment doesn't seem to be, like an overnight experiment. So do you have a rough estimate on how much time you've spent on this?
Well, a few weeks, but it's only because like I had to translate code from Python to C++. That was a whole waste of time. I had to figure out like some of these libraries, using them for the first time. I had never used PyLab-Cut. Like it's not as friendly as, like, I don't know if any of you have used MediaPipe or something to that effect, or even Azure. They also have pose estimation stuff. Like, a lot of these APIs are more friendly to developers, but PyLab-Cut, not. I mean, it's great, but it was made for neuroscientist researchers, so it's not very friendly. So I had to figure that out, and also, yeah, I think I put a lot of attention on details that in the end didn't matter. So had I followed like what I talked about in the takeaways and the lessons learned, had I done some of those steps first, perhaps I would have cut it down to like a week or two. Yeah.
He was like, what else should I have to say? I have a microphone. I don't know what to do. Give it back. Any more questions? Well, I can wait. We have 20 minutes. You have one more question. Let's go. Don't give the microphone back next time.
Yes, I have another question, because maybe I misunderstood here, but you were mentioning that one of the takeaways was that you could have used a top-mounted camera.
Yes.
But with a top-mounted camera, wouldn't you have missed out this critical information that when, the lower part of the dog is lowering?
Well, that's why I wanted top-mounted with an angle towards the panel.
Okay.
Yeah.
Okay, I give you 3 seconds. Do you have a third question? Because why should I stand up and sit back down? I mean, hello. Okay, any more questions? Thank you. Thank you. We really have time.
Hi, is the end of tail is not important, or it is not important in this particular case? I mean, when you create a model with kind of dots, why did you put a dot on the end of tail of the?
A what? A dot at the end of the tail. It could be, but the thing is, the original, the DLC, the Deep Lad Cup model, does not have one. Which means that if I wanted to put a dot at the end of it, I would have to train a new model, a new data. This is not even something I can expand somehow with, by fine-tuning the model or something like that. I really have to retrain a new model. And that means labeling data. That would have taken a lot more, you know.
Anyone else feeling curious today? Thank you. Jesus, the second of me waiting for somebody to raise the hand is very stressful. Here you go.
Thank you very much. Did you think about that? Create a distributed system, so the first model would be used just to pose detection. Then the output of this model could be sent to the top model to figure out the gesture.
Yeah, that's how I originally envisioned it. There's several ways of approaching it.
Yeah,
Like
yeah, of course.
you could theoretically skip the pose detection and just come up with a convolutional neural network connected with a gesture classification model, right? And it would probably be like a similar architecture, like a recurrent neural network with the CNN component. You could have that, but you would need a lot more videos to make that work, because it's just so much denser information. There's a big difference between, like, at any given point, at the end I ended up with 2 seconds. That was 20 frames. So that's 20 times, I think it was not even 10 body parts, but let's say for the sake of, maybe 400 pieces of information for every given moment, tops. But if you're doing a video, the actual video, that becomes very multidimensional, because you're already talking about every frame. I forget. You're already talking about 10,000 or so data points, because it's the width and the height of every image times the time steps, which is 20. So it's a lot. I think it would have taken a lot of videos to make that work. But it's a valid point. Well, honestly, I don't know. Does that answer your question, or was it?
Yes or no? Because the last part of your presentation was about the latency.
Yeah.
That's why you had to change from Python to C++.
Yeah.
Which is, I think it's a good idea, but probably it could be improved as well if you use one Raspberry Pi for the image processing, but only for processing, and use the first model on it, and the output of this image processing and the first model application on the data could be digested or sent to another Raspberry Pi.
Yeah. Okay, I get what you're saying. Yeah.
Some kind of distributed
I did
system.
not. The problem is I didn't have to. I mean, I did this project, just to give you an understanding. This project, I did this earlier this year when there was a shortage of Raspberry Pis. Hence the fact that I used an old Raspberry Pi. Now I have a 4, which is better. But, I didn't have enough of them lying around. But yeah, that would have made sense. Another thing was, I had to have like multiple, I thought of having multiple cameras, but I didn't have more. And that would have made it better had I had multiple cameras. Not only because I would have been able to, make some kind of, traditional CV magic where I'm like connecting 2 points and turning into 3D, but I'm also be able to, maybe with another camera, evaluate, which is not something I was doing, because as I said, it was open-ended. I thought, well, how do I evaluate this? the only way I can evaluate it is if I have a camera always running, you know, and doing some kind of processing to detect if it worked or not, versus the one that is actually doing the inference of the model. So having those two cameras would have slowed my single Raspberry Pi down already. So latency was already a problem. I didn't want to make it even more of a problem.
Okay, thank you very much.
Okay, we do have time for one more question before lunch. Pass the microphone, please.
So thank you for the presentation. My question is, so in the end, you said it's you did the project in early this year. So how it affected Tilly? Did it have some effect in the end, or?
Yeah, we clean up after her a lot less. I can tell you that. I mean, it still happens, but it happens a lot less. We moved, so I couldn't no longer use the system because you know, everything was set up for a very specific. I mean, I would have had to retrain at least the pad precision model, because if of course kind of, even though I don't want to, it takes into account the kitchen counter and other things in the calculation of where the points are. So I had to stop using the mechanism, but I think it did have an effect. It's hard to measure because I honestly wasn't measuring that before. It's not like one day I'm like, oh, I've had 2 accidents today and I had one yesterday. I didn't have a tally of it. I just knew it was a lot. You know, every time I came out of a meeting from work, because I work remotely, I would have to clean up after her. And now it happens like maybe once a week there's an accident. So yeah, I would say it's been positive.
Oh, thanks.
Okay, I think that's it for the questions because the lunch is ready and we will meet you back here and in other stages in an hour.
Would you mind a selfie before you all go?
Well, if they are ready to look very happy and excited for the puppies.
Yeah. I'm excited for Vilnius.
Everybody say puppy love. Thank you. Okay.
Thank you.